Welcome to Q&A Wire.
So, in this question, we are told to explain why BRF4 minus is square planar and BF4 minus is tetrahedral. Well, Br is in group 7, so it has a 7 valence electron. And if you're considering BRF4 minus, you have bromine is in group 7, so you have 7 valence electron and you have 1 of it. And fluorine is also in group 7 and you have 4 of it. And you have this minus, so that means you've gained 1 electron. So total number of electrons is going to be 7 plus 28 plus 1. So that is 8 plus 28, so that's 36 electron. So if you draw the Lewis structure, it's going to look like this. Then you're going to have you have 6 electrons on each fluorine. So that's 6 times 4, that's 24. And each of this bond has 2 electrons. So that is 1, 2, 3, 4. So that is 8. So 24 plus 8 will give you 32. And okay, so you have 6 electrons on each fluorine. And you have 4 of them, so that's 6 times 4. So 24. And you have 1, 2, 3, 4. 4 bonds, so that is 4. Each of them has 2 electrons. So that's 8. So that's going to be 32. So 7, 7, 1. So 7 plus 28. 5. Yeah, so that's 32 electrons already. So we need 4 more electrons. So now we need to put those 4 electrons as non-bonding electrons. All right, so to put them as non-bonding electrons, we have them look like this. So that makes 36. So that's plus 4 is 36 electrons. Whereas when you come to BF4 minus, so BF4 minus, you have boron is in group 3 and fluorine is in group 7 plus 1 because of the minus. So that's going to be 3 plus 1, that's 4. 4 plus 28, so that's 32 electrons. So if you draw that, so that's going to be F, you have F, then you have F, right? So if you put those 6 electrons on each of the fluorine atoms, and then you already have 4. So, and then you already have 2 in each of the bonds, and you have 4 bonds. So that's 32 electrons straight. So the shape of the molecule will look like this. And this is tetrahedral. So like you can see, the structure of BRF4 is square planar because we have a lone pair of electrons that cause the 4 boron, or that cause the 4 bromine fluorine bond to be pushed to the plane because of the lone pair, and the lone pair bond and pair repulsion. In the BF4 minus, we don't have any lone pair, so the geometry of this to minimize repulsion will be tetrahedral. And here for the B part, we are told that how will we expect the H hex H bond angle to vary in this series. So we have H2O, we have H2S, we have H2SE. So how would we expect the bond angle to vary? So the bond angle in H2O will be around 104.5 degree, and this will be around 92.3 degree, and this would be around 91.0 degree. Okay, and that is because of lone pair repulsion. The lone pair open up slightly in order to reduce this repulsion, thereby forcing the HX angle to contract slightly. So, and that is why normally we expect the H2O to be around 109 degrees Celsius, 109 degree, but because of this lone pair repulsion, it contracted to like shape all the way down. To like 104.